Hi, hello dear students. Welcome to our channel Maths with Panindra. In this video, we are going to discuss about probability. We are in exercise 9C in the first bit question number 12. The probability that a boy A will get a scholarship is 0.9 and another boy B will get is 0.8. What is the probability that at least one of them will get the scholarship? See, first you have to understand the question thoroughly. Then what formula here we have to apply. So let us see that. A and B, two persons are there. They are getting the scholarships. Two persons are there means they are individual. That means independent. That two persons A and B which are independent events. Clearly we are getting from this information. So first their probability is also given now. So one by one we will write it. A be the event that the boy will get the scholarship. Will get the scholarship. So the probability of the boy A will get the scholarship is P of A is equal to, how much it is given? 0.9. This is the first step. Similarly, second step also. B be the event that, simple lines. B be the event that the boy means another boy here. The boy will get the scholarship. So B boy will get the scholarship is, how much it is given? 0.8. So P of B equal to 0.8. From the observation, they are getting individually, So A comma B are independent events. Independent events. So next, what is the probability that at least one of them will get the scholarship? I already discussed in the last video. At least one of them. Here two persons are there. Two boys are there. The probability that at least one of them means either a boy will get or a boy B will get scholarship. Either or means A union B. So whenever it is A union B, probability of A union B is required. P of A union B is required. The meaning of probability of A union B is the probability that at least one of them will get the scholarship. So P of A union B, conclusion step. The probability that at least one of them will get the scholarship. Will get the scholarship is P of A union B. By using addition theorem on probability, P of A union B we can write it as P of A plus P of B minus P of A intersection B. Since the persons are independent, whenever the events are independent, P of A intersection B can be written as P of A into P of B. So which is equal to P of A plus P of B minus P of A into P of B. So therefore, P of A union B is equal to P of A value 0.9 plus P of B value 0.8 minus 0.9 into 0.8. So 0.9, 0.8, 1.7 minus 0.9 into 0.8. 9 as a 72 means 0.72. So 1.70, 0.72. So here 8. So here 6 will be there. 9. So not this one. So 3, 8. 0. Next here. 16 minus 7 is 9. Here 0 will be there. If you add these two, you will get it as. So that is equal to 0.98. Therefore, the probability of getting at least one of them is 0.98. We'll move on to the next question, dear students. So here, the question number 13. If A, B are two events with P of A union B equal to 0.65 and P of A intersection B equal to 0.15, then find the value of P of A complement plus P of B complement. So first, whatever the information is given, you have to write it. Capital A comma capital B are two events. A comma B are two events. Given that P of A union B is equal to 0.65 and P of A intersection B is also equal to 0.15. This information is there. They are asking to calculate P of A complement plus P of B complement. So by addition theorem on probability, we have the addition theorem on probability states that P of A union B is equal to P of A plus P of B minus P of A intersection B. So the known values first substitute. P of A union B 0.65. P of A value we don't know. Plus P of B value also we don't know. Minus P of A intersection B 0.15. So minus 0.15 we can take this side. 0.65 plus 0.15 is equal to P of A plus P of B. 0.65 plus 0.15 is 0.8 is equal to P of A plus P of B. Put it in box. This result we will use in the coming steps. What they are asking to calculate the value of P of A complement plus P of B complement. P of A complement plus P of B complement equal to. We know that P of A plus P of A complement is equal to 1. From that, P of A complement can be written as 1 minus P of A. P of B complement is 1 minus P of B. So which is equal to 1 plus 1, 2 minus take common P of A plus P of B. So we know the value of P of A plus P of B from here now 0.8. So which is equal to 2 minus 0.8 which is equal to 1.2. Therefore, the value of P of A complement plus P of B complement is equal to 1.2. I hope you people understand. We'll move on to the next question. Yeah, the next question number 17. Sorry, question number 14. If A, B, C are independent events, show that A union B and C are also an independent events. See, simply X comma Y are independent means simply you have to prove P of X intersection Y equal to P of X into P of Y. This information we need to prove. So in place of X comma Y, we have A union B and C. So first step you have to write it given A, B, C are independent events or independent events. Where it will be independent events? In the sample spaces, generally it is. So after that we need to prove A union B intersection C. So now consider to prove that. Consider the probability of A union B intersection C. A union B intersection C. This is a very important step, dear students. Why we are considering? To prove X comma Y are independent, what we are considering? P of X intersection Y. In the same way, to prove A union B and C are independent events, we have to consider P of A union B intersection C. So from De Morgan laws, in the earlier classes we discussed that A union B intersection C. From De Morgan laws we can write it as A union C. Sorry, here intersection is there no common. A intersection C union B intersection C. I hope you people understand by using De Morgan laws. Second important point. So by using this property, probability of A union B intersection C can be written as P of A intersection C union B intersection C. Now it is in the form of P of A union B. By using addition theorem on probability, we can write it as P of A intersection C plus P of B intersection C minus P of A intersection C intersection B intersection C. By using addition theorem on probability, we are writing like this. After that, since A, B are independent events, A, C are independent events, A intersection B, A intersection C can be written as P of A into P of C. See here, one more step. A comma C are independent. Then P of A intersection C can be written as P of A into P of C. Similarly, B intersection C. So B comma C are also independent. So we can write as P of B intersection C equal to P of B into P of C. So by using this independent concept, P of A into P of C plus P of B intersection C can be written as P of B into P of C minus again A intersection C and B intersection C. A intersection C intersection B intersection C is common only now. So P of A intersection B intersection C Again, A, B, C are independent events. Here, one more result. This is the first one, this is the second one, this is the third one. A, B, C are independent. So then P of A intersection B intersection C equal to P of A into P of B into P of C. We can write like this. I hope you people understand, your students. We'll move on to the step. So P of A into P of C plus P of B into P of C minus P of A into P of B into P of C. So in every term P of C is common, you take out common. P of A plus P of B minus P of A into P of B. From these three terms, we are taking common P of C. Again, from addition theorem on probability for the two events, P of A plus P of B minus P of A into P of B, we can write it as P of A into P of B, we can write it as P of A intersection B. So now, P of A plus P of B minus P of A intersection B into P of C. P of A plus P of B minus P of A intersection B is P of A union B only, no? So which is equal to P of A union B into P of C. So whenever P of A intersection P of A union B intersection C can be expressed as P of A union B into P of C. That implies that A union B comma C are independent events, are independent. That's what they are asking to prove. Hence, it's proved. We'll move on to the next question, dear students. The next question, question number 15. A, B are two independent events such that the probability of both the events to occur is 1 by 6 and the probability of both the events do not occur is 1 by 3. Find P of A. A, B are two independent events such that the probability of both the events to occur, here only important information. First, if you find this value, you will get the complete answer. Why? Because some students will fail to understand this concept only, first step. The probability of both the events to occur means probability of A intersection B. And second one, the probability of both the events do not occur, P of A complement intersection B complement, or P of A union B whole complement, both are same. So first you write the given information. A, B are two independent events A, B are two independent events. So that information is there. Next, given the probability of both events to occur, the probability of both events to occur is 1 by 6. That is, P of A intersection B is equal to 1 by 6. Keep in mind, dear students, here. Whenever they are independent events, we can write P of A into P of B, no? Which is equal to 1 by 6. In the question, they are asking P of A. So, P of B, in terms of P of A, you have to write it. So, from this, P of B is equal to 1 by 6 into P of A. This value, put it in box. This will help in the coming steps. P of B value we got it. Next, another information is there. The probability of both the events do not occur given the probability of both events do not occur is 1 by 3. That is P of A complement intersection B complement is equal to 1 by 3. Whenever they are independent events, A comma B, since A, B are independent, that implies A complement, B complement are also independent. So A, B independent means their complement is also independent. So we can express as P of A complement into P of B complement is equal to 1 by 3. We know that P of A complement means what? 1 minus P of A. P of B complement means 1 minus P of B is equal to 1 by 3. In place of P of B, you replace with in terms of P of A. So that implies that 1 minus P of A into 1 minus 1 by 6 times of P of A is equal to 1 by 3. So P of B value is 1 by 6 times of P of A. That you have to simplify. So that implies that 1 minus P of A into, take LCM here, 6 times of P of A. So 6 into P of A minus 1 is equal to 1 by 3. So here 3 ones, 3 twos. Cross multiply. And here 1 minus P of A, 6 times of P of A minus 1 is equal to 2 times of P of A. So actual multiplication 1 into 6, so 6 into P of A, 1 into minus 1, minus 6 into P of A whole square, minus P of A into minus 1 plus P of A. 2 P of A also we can take this side, minus 2 into P of A is equal to 0. First square term, minus 6 into P of A whole square, 6 P of A plus P of A. So 7 P of A minus 2 P of A. So it will become 7 minus 2, 5. 5 into P of A minus 1 is equal to 0. Multiplying by minus throughout this equation. 6 times of P of A whole square minus 5 times of P of A plus 1 equal to 0. Factorization we need to do that. 6 into 1, here minus 5 we need to get it. So 6 times of P of A whole square, this can be written as minus 2 P of A into minus 3 P of A plus 1 equal to 0. From these two, 2 times of P of A, from these two minus 1. So 2 times of P of A, if you take out common, 3 times of P of A minus 1, minus 1 if you take out common, 3 times of P of A minus 1 is equal to 0. So 3 times of P of A minus 1 into 2 times of P of A minus 1 is equal to 0. So either this value 0 or this value 0. 3 times of P of A minus 1 equal to 0, or 2 times of P of A minus 1 is equal to 0. So 3 times of P of A is equal to 1. So P of A is equal to 1 by 3. So this is one of the values of P of A. Or 2 P of A is equal to 1. So P of A is equal to 1 by 2. Either the value of P of A is 1 by 3 or 1 by 2. Therefore, the possible values of P of A. Find P of A they are saying now. So we got either 1 by 3 or 1 by 2. Both the possibilities are there. If we check that P of A intersection B, whether it is 1 by 6 or not. Suppose if you are taking 1 by 3, P of 1 by B will become obviously 1 by 2. So P of A is 1 by 2. If you take P of B value, obviously it is 1 by 3. After that, the product of these two, P of A and P of B, if you do the product, it will become 1 by 6 only. So correct answer. This is the verification I am saying. We will move on to the next question. The next question number 16. A failed die is rolled. Consider the events A, B, C. A failed die is rolled. What are the total possibilities? S is equal to 1, 2, 3, 4, 5 and 6. A failed die is rolled. These are the total number of possibilities. So that implies that n of S is equal to 6. So A equal to given events. This is the given information. These are the sample space for rolling a die. A failed die rolled, then S is equal to A is equal to 1, 3, 5. So n of S, how many possibilities are there here? 3 possibilities are there. Next B, how many possibilities are there? 2, 3. 2, 3. 2 possibilities. Therefore, n of B is equal to 2. C is equal to 2, 3, 4, 5. 2, 3, 4, 5. So n of C is equal to 4. So first individual probability you calculate. P of A is equal to n of A by n of S. So n of A means 3 by 6, 1 by 2. N of B. So P of B is equal to n of B by n of S. So 2 by 6, 1 by 3. P of C equal to n of C by n of S. 4 by 6, that is equal to 2 by 3. After that, to calculate intersection, we need to do that A intersection B and B intersection C, C intersection A. So A intersection B, in this what are the common things? 3, only 3 element. So that implies that n of A intersection B is equal to only one element. So obviously P of A intersection B is equal to what? N of A intersection B by N of S. So 1 by 6. P of A intersection B value 1 by 6. Next B intersection C. 2, 3 is common numbers. So 2, 3. That implies that N of B intersection C. So 2 elements are there. So P of B intersection C. So n of B intersection C by n of S. So 2 by 6, 1 by 3. Similarly C intersection A. 1, 3, 5. Here 3, 5 is common. So common elements 3, 5. So n of C intersection A is equal to 2. That implies P of C intersection A is equal to n of C intersection A by n of S, which is equal to 2 by 6, 1 by 3. So complete information we got it. One by one we will do that. So first one, P of A intersection B, we got it here 1 by 6. P of A union B. First question, P of A intersection B. Here directly I am writing. We already discussed here 1 by 6. Next, P of A union B. P of A plus P of B minus P of A intersection B. So P of A value 1 by 2, P of B value 1 by 3 minus P of A intersection B 1 by 6. So LCM 6. 3 plus 2, 3 2s are minus 1. 5 minus 1 is 4, 4 by 6, 2 by 3. So P of A union B is equal to 2 by 3. So P of A intersection B, we got it here. Now come to the second question. Here we will finish it. Question number 2. P of A given B. By definition of condition probability, P of A given B means P of A intersection B by P of B. So P of A intersection B 1 by 6 by P of B 1 by 3, which is equal to 1 by 6 into 3 by 1, that is equal to 1 by 2. So P of A by B value is 1 by 2. Similarly, P of B given A. So P of B intersection A by P of A. P of B intersection A is also 1 by 6 by P of A value is 1 by 2. So 1 by 3, 2 ones are 2 3s are 1 by 3. Now A given C, third one. P of A given C is equal to P of A intersection C by P of C. P of A intersection C, we got it here. P of A intersection C 1 by 3 by P of C. P of C is also 2 by 3. So 3 3 get cancelled, 1 by 2. Next, P of C by A. C given A. P of C intersection A by P of A. We know that C intersection A or A intersection B, C, both are same. So it will be equal to 1 by 3. By P of A value is also 1 by 2. P of A's value is 1 by 2. So 1 by 3 by 2 by 3 means 2 by 3 will come here. Denominator of denominator, numerator. P of C by A. Now come to the fourth one. P of B by C. So P of B intersection C divided by P of C. P of B intersection C 1 by 3 by P of C value 2 by 3. P of C 2 by 3. So 3 3 get cancelled, 1 by 2. P of C given B. P of C intersection B divided by P of B. P of C, that is 1 by 3, C intersection B. P of B value 1 by 3. So 1 by 3, 1 by 3 get cancelled, 1. This is the way they will ask any two of them, any one of them, they will ask for 2 marks or 4 marks. Dear students, keep in mind, this is the way you can work out. This is the very important step. If a die rolled, so the total possibilities are getting 6, N of S. After that, according to the sets A, B, C events are given. Based on that, we can do that. We'll move on to the next question. Next question number 17, dear students. If A, B, C are 3 events in a random experiment, prove that the following. So here total 7 questions are there. One by one I will explain. Come to the first question. The first question, you have tried them the first given A, B, C or 3 events in a random experiment. So consider the first one. P of A given A is equal to, they are asking to prove this result as 1. So first question. By definition of condition probability, P of A by A can be written as probability of A intersection A by P of A. A set is there, another set is also A. A intersection A, common element is what? A set only, no? So P of A intersection A is equal to A itself. So it will become as A. P of A intersection A is P of A by P of A. So both will be cancelled, which is equal to 1. So first question we proved that P of A given A is equal to 1. Come to the second one. P of second one null set pi by A. So null set, how to write? The relation between null set and A. The intersection part of null set. So probability of, by definition of condition probability, for this P of probability of null set intersection A by P of A. The null set and a set intersection is null set itself. So the probability of null set is always 0. So that is the reason this value, probability of phi divided by P of A, probability of null set is always 0. 0 by P of A, that is equal to 0. So second one also we proved that. Come to the third one. A is subset of B and implies that we have to prove P of A given C is less than or equal to P of B given C. If you draw the small figure, you will get idea. So this is the generally I am writing generally. Suppose if we take this one as A, this one is B, and this one is C. A is subset of B or not, we will verify from this figure. Easy to. So A is subset of B, that implies that A is subset of B. And the element, if you take here relation between A and C, B and C also we need to take now. So first A and B I am taking here, A and B. Sorry, A and C. The intersection A and C, the elements A and C, the elements which are belongs to B and C. In that anyway common elements are there. So these two sets A and B linked with C means common. So how to take common? A intersection C, both sides you have to take that intersection. B intersection C. A is subset of B. A intersection C is also subset of B intersection C. A, C and BC here. BC is outer set now. So obviously A intersection C value should be subset of B intersection C. After that, take probability on both sides. Whenever we are taking the probability, this subset will become less than or equal to. So probability of A intersection C is less than or equal to probability of B intersection C. By definition of here, they are asking to prove in both the results denominator C now. So dividing on both sides by C. Dividing on both sides by C. P of A intersection C by P of C is less than or equal to P of B intersection C by P of C. By definition of condition probability, P of A intersection C by P of C can be written as P of A given C is less than or equal to P of B intersection C by C is P of B given C. Hence proved A is subset of B implies that P of A given C is less than or equal to P of B given C. I hope you people understand, dear students. We'll move on to the question number 4. P of A minus B is equal to P of A minus P of A intersection B. See how to do this type of things. For this, this is related, this figure is related to Roman letter 3. For Roman letter 4, the figure will come like this, my dear students. So this is B, this is A, this is A intersection B. This part is this part. A intersection B complement. A intersection B complement or A minus B only. Why? Because this is completely A. In that B is we are subtracting. So A minus B. So from the figure, A minus B taking as, in this A, we are subtracting A minus B, A intersection B. So A minus A intersection B. A minus B means A intersection B. See here, this one, P of A minus B. So taking probability on both sides by using axioms. So probability of A minus B is equal to probability of A minus A intersection B. By using axiom of unity, we can write it as P of A minus P of A intersection B. Hence prove that fourth result. I hope you people understand, dear students. I'll rub this board and I will explain the rest of the concepts. P of A minus B equal to A minus A intersection B. Suppose if it is B minus A intersection B, you can write it. Even A intersection B complement is also same. A intersection B complement can be written as A minus A intersection B. A minus B is equal to A intersection B complement. You remember, dear students? B is getting minus now, so that is the reason here complement. We will move on to the last three here in that question. Now, the next question, question number 5, dear students. In this A, B are mutually exclusive. We know that A comma B are mutually exclusive. Then the probability of P of A intersection B should be equal to 0. A comma B are mutually exclusive. Then P of A intersection B is equal to 0. Now come to the question. P of A given B is equal to, they are asking to prove this result as 0. I will prove it. P of A given B, by definition of condition probability, P of A intersection B by P of B. Provided that P of B is not equal to 0. They mentioned that not equal to 0 means greater than 0. So whenever P of A intersection B is 0, 0 by anything is 0 only, no? So hence proved P of A given B equal to 0 when A, B are mutually exclusive. Conditions apply here, dear students. Even in the objective also, in MCQs, they make chances to ask, if A, B are mutually exclusive and P of B is greater than 0, then P of A given B is equal to 0. So now come to question number 5. I will finish it all at one place. So question number 6. A, B are mutually exclusive. Again, same case. A comma B are mutually exclusive. Then P of A given B complement equal to, whenever P of A comma B are mutually exclusive, then P of A intersection B is equal to 0 only, no? It will be same. P of A intersection B is 0. But they are asking to prove this result as this one. So P of A given B complement is, by definition of condition probability, P of A intersection B complement by P of B complement. So A intersection B complement, just now I draw one figure here. So that can be expressed as, from set theoretical distribution, P of A intersection B complement can be written as A minus A intersection B by P of B complement means 1 minus P of B. Again by using probabilities axiom of unity. So P of A minus A intersection B is P of A minus P of A intersection B whole divided by 1 minus P of B. Since P of B union P of A intersection B equals 0, this will becomes P of A by 1 minus P of B. Since P of A intersection B is equal to 0. So P of A given B complement is equal to P of A by 1 minus P of B. When P of B is not equal to 1 by, because denominator is there now. So it should not be equal to 0. provided that P of B is not equal to 1. Come to the last one, Roman letter 7. Here also same case, A comma B are mutually exclusive events. Mutually exclusive. So P of A intersection B is not is equal to 0. Now what they are asking here, P of A given A in union B. So by definition of condition probability, P of A intersection A union B by P of A union B, which is equal to, by De Morgan laws, if you apply here, probability of A intersection A union A intersection B whole divided by P of A union B. Again, A intersection A union P of A intersection B. By using axiom of unity in probability, P of A intersection A plus P of A intersection B by P of A union B can be written as P of A plus P of B minus P of A intersection B. So by using, since the events are mutually exclusive events, so P of A intersection B goes to be 0. So this value goes to be 0. So P of A intersection A by P of A plus P of B. So wherever P of A intersection B is there, that value goes to be 0. So A intersection A, two events are same, so intersection part is A only, no? So that is equal to P of A given, P of A by P of A plus P of B. Hence proved P of A given A union B equal to P of A by P of A plus P of B when A comma B are mutually exclusive events. I hope you people understand, dear students. We'll move on to the next question. The next question, dear students, question number 18. Suppose that a coin is tossed thrice, that means 3 times. Let A be getting 3 heads. B be the event of getting a head on the first toss. Show that A and B are dependent events. They are not asking to prove that independent. Dependent events. See here, the solution will begin with like this. Coin tossed 3 times. Coin tossed 3 times. Then total possible outcomes. Total outcomes are S is equal to, observe carefully, dear students. Generally, 3 times the toss will be there. The toss 3 times, a coin. 2 power 3, that is equal to 8. What are the 8 possibilities? I am writing here. H. In the first toss, second toss, third toss, like this. Next T. Next H. Next H. Next all tails. First toss, second toss, third toss, all tails only. Next TH. Next THT. Next HTT. These are the 8 possibilities we have. N of S is equal to 8. I hope you people understand, dear students. Next, A is equal to getting 3 heads. Getting 3 heads among these 8, only this possibility, no? H. So that implies that N of A is equal to only 1. So therefore P of A is equal to what? N of A by N of S, 1 by 8. So therefore P of A is equal to N of A by N of S, 1 by 8. Next, B equal to getting a head on the first toss. So what are the possibilities from this? First toss, head will be there. So H, this one is also first head is there. Now H, 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 T. Next H, T, H. Next here H, T, T. So how many are there? 4 are there. So N of B is equal to 4. Therefore, the probability of B, P of B is equal to N of B by N of S. So N of S is 4 by 8, which is equal to 1 by 2. So P of B value 1 by 2, we got it now. So therefore, P of, here conclusion I am giving, P of A is equal to 1 by 8. P of B is equal to 1 by 2. Next, A intersection B. What are the common things? A intersection B. So in A, only H, H, H is there. In B also, H, H, only one. One is common. H, H, H. So that implies that N of A intersection B is equal to 1. Therefore, the probability of A intersection B, P of A intersection B is equal to N of A intersection B divided by N of S. So 1 by 8. They are asking to prove A and B are dependent events. So to prove that, consider P of A intersection B. So P of A into P of B, first I will write it. P of A value is what? 1 by 8. Sorry, P of A is 1 by 8. P of B value is what? 1 by 2. 1 by 16. This is P of A into P of B value. P of A into P of B. Equation number 1. P of A intersection B is what? 1 by 8. So they, from 1 and 2, generally, P of A intersection B is not equal to P of A into P of B. That implies that A comma B are not independent. They are not independent event means what? Therefore, A comma B are dependent events. Dependent events. Hence, proved. I think you people understand, students. We'll move on to the next question. The next question, question number 19. Suppose that an unbiased pair of dice is rolled. Let A denote the event that the same number shows on each die, let B denote the event that the sum is greater than 7. Suppose that an biased pair of dice is rolled. We already discussed in the last sessions. A pair of dice rolled means S is equal to sample space 6 square 36, 1 comma 1, 1 comma 2, 1 comma 3 and so on 1 comma 6. Like this 2 comma 1, 2 comma 2, 2 comma 6. 6 comma 1, 6 comma 2, 6 comma 3 and so on 6 comma 6. These 36 possibilities are there in N of S. So in the solution step, the pair of dice rolled, then N of S is equal to 6 square, that is equal to 36. No need to mention, we will write it. S is equal to 1 comma 1, 1 comma 2, 1 comma 3 and so on 1 comma 6, like this 6 comma 6, 36. Next, given A denote, A is equal to what A represents? The event that the same number shows on each die. So we will write it easily. A is equal to 1 comma 1 in the first die, second die. Same number is showing. Like this 2 comma 2. Like this 3 comma 3, 4 comma 4, 5 comma 5. And 6 comma 6. So how many are there? 6 possibilities are there. N of A is equal to 6. Therefore, P of A is equal to N of A by N of S, 6 by 36, which is equal to 1 by 6. Next, B be the event that denote that event sum is greater than 7. The event that the sum is greater than 7. So greater than 7, sum is number. So like 1 plus 1 is 2, it is not possible. Like this, whichever the number's sum on the dice is greater than 7, that you have to write it. So in 1 comma 1, 1 comma 2 like this, if you take 1 comma 6, not possible, that also. So in the 1 1 1 2 series it won't come. But 2 1 series is there. 2 comma 6 is there, 8 more than 7. Next in the 3 3 1 3 2 3 3 like this, 3 is 5 more than 8 only, no. So 3 6 more than 8 more than 7. Next 4 table, not 4 table, like 4 series, like 4 2 not 4 3 4 4 4 5 4 6. Next 5 3 5 4 5 5 5 6. Next 6 6 2 6 3 6 4 6 5 and 6 6. So how many are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So N of B is equal to 15. So therefore P of B is equal to N of B by N of S. So 15 divided by 36. 3 table, 3 5s are 3 12s are. So 5 by 12. This is P of B. Intersection also calculate. Why? Because P of A given B, condition probability. A intersection B. So in these, what are the common things? The sum of 4 comma 4 is there. 4 comma 4. Next 5 comma 5 is also there. Next 6 comma 6 also there. Other numbers are not possible. Why? Because less than 7 which are. These are not possible. So common n of A intersection B. How many are there? 3 possibilities are there. So therefore P of A intersection B is equal to. So n of A intersection B divided by n of S. So n of A intersection B is 3, n of S is 36. 1 by 12. 3 ones are 3 12s are. So this is about P of A intersection B. Now come to the first question. Two questions are there. First question, P of A by B. That means P of A intersection B divided by P of B. P of A intersection B 1 by 12 divided by P of B value is 5 by 12. So 12 get cancelled. 1 by 5. So this is about P of A by B or A given B. Similarly, the second one, P of B given A or B by A. So P of B intersection A by P of A. So P of B intersection A. What is P of B intersection A? A division B, B intersection both are same. 1 by 12 by P of A. P of A is 1 by 6. So which is equal to 1 by 12 into 6 by 1. 6 ones are 6 twos are. So therefore P of B by A is equal to 1 by 2. I hope you people understand. We'll move on to the next question. The next question. Prove that A and B are independent events if and only if P of A by B equal to P of A given B complement. So first we will take it this given condition and we are going to prove that the events are independent events. See here, first let us consider this event. If and only if is there, but I am considering now. Consider P of A given B is equal to P of A given B complement. P of A given B, by definition of condition probability, P of A intersection B divided by P of B, which is equal to P of A given B complement. P of A given A intersection B complement by P of B complement. We know that we discussed in the last class itself, in this class only, in this session only, A intersection B complement can be written as A minus A intersection B. A intersection B complement meaning is A minus B itself. So, in place of A intersection B complement, I am going to write this one. So, P of A intersection B by P of B is equal to P of A minus A intersection B by P of B complement 1 minus P of B. By using of the axioms of unity, P of A minus A intersection B can be written as P of A minus P of A intersection B. So that implies that P of A intersection B divided by P of B is equal to P of A minus P of A intersection B by 1 minus P of B. Cross multiply these values. So P of A intersection B into 1 minus P of B is equal to P of B into P of A minus P of A intersection B. So that implies P of A intersection B minus P of B into P of A intersection B is equal to P of B into P of A minus P of B into P of A intersection B. So minus P of B into P of A intersection B on both sides, you have to cancel it. That implies that P of A intersection B is equal to P of B into P of A. So whenever we are writing P of A intersection B as the product of P of A and P of B, that implies that A comma B are independent events. Independent events. Hence proved. Hence the result. Thank you dear students for watching our channel. If you have any doubts regarding this session, please write to my comment box. I will help you in my free time. Thank you for your supporting. Signing off, Maths with Panindra. Jai Hind.